Hello everyone, welcome back. Today we are discussing about AP as average precision. Precision. Last time we discussed about F1 score and map. F1 score is provided by the harmonic mean, that is P times R over P plus R. While map mean average precision is provided by the average of summation of APs. Last time we didn't go deep into AP, how AP is found or deduced. That's why I'm making this video to explain how AP is found. AP or average precision is provided by integral from 0 to 1 of precision of R, or as function of R, dr. Or if you want, precision or recall the recall. Do you remember this mathematical expression? Average equals one b minus a integral from a to b of f x dx. Do you remember it? And do you remember that this means the area, the calculation of area from A to B, this calculation of this area. With A and B being intervals where A and B are intervals. If you remember that, it's easy to get the concept of AP. Because with AP, as you know, AP varies from 0 to 1. It can't go beyond that. AP intervals must be zero included to 1 included or inclusive. So applying the formula, if we apply this formula to precision as a function of recall, we'll have this precision as the function of recall. We'll have this B being 1 and A being 0, 0 to 1, P of R, D, R. That's going to be 1 over 1. That's 1. So we have this P R D R, and this is going to be average precision. But what calculating, we saw it a little bit earlier. What we want to calculate is if you have a recall and the function precision p, we'll have values. Say we have values giving us these points, and we'll be able to draw and this is 0. Let's say 1 reaches here. So we want to calculate this area under the curve. The calculation of this area, that's the AP. As you remember, the model will provide a recall. The model itself will calculate recall. It's its job. And P will be calculated. You know how they are calculated? From false positives, false negatives, true positives, true negatives. You remember. So we'll get points at a given threshold. Threshold is like a cutoff point, like a certain confidence. The confidence is calculated based on overlap between ground truth bounding box or labeled bounding box and predicted bounding box. That something similar to if you have this actual bounding box, or if you want ground truth bounding box, that's your label. If you have this and the model in its prediction on new unseen image, it draws this bounding box as predicted. Or just prediction. This area is the intersection. This area is the intersection and in this intersection that's where the ground truth meets the prediction. And if this intersection is huge, is big, actually if it tends to have the same size as the ground truth bounding box, it means the prediction will be tending to be more accurate, or how it will be tending to have high precision. So this is what we refer to as intersection over union. This is intersection over union. Union is when we take all the bounding boxes together like this. We take all this union and then we take this intersection. When the ratio of intersection over union will show us the precision, how precise the model is detecting the location of the object on the image. In the next video, I'll discuss more about IU, intersection over union. Today, let's focus on AP, and let's make some calculations. Let's come up with some example of how we can calculate the AP based on recall values and precision values. Let's say the model gave us the following values. We have recall, we have precision. For recall, let's have 0, 0, 1, 0, 5, 0, 8, 0, 7, 5, 0, 6, 1, 0, 4. And we are asked to calculate the AP area. Calculate AP. As you know, AP is the area under the precision recall curve. Let's use trapezoidal integration. Let's use the method of trapezoidal integration. Do you recall the formula for AP? AP this means if you would take discrete points, that's going to be a summation. It means I from 1 to n recur from recur I to recur I minus 1 times P R index I. Okay, do you remember this? Let's say we have R index I. At a certain point, we have a value of R. The previous value is R I minus 1. Okay, so let's go. Let's first calculate intervals. To calculate intervals, calculation, we have interval from R1 back to R0, and we have 0.5 minus 0. That's 0.5. Then R2 minus R1. Yeah. This is actually R0. This is R0. This is R1. This is R2. This is R3. Okay, so this is P. This is P. P for R0. This is P for R1. This is P for R2. This is P for R3. Or just P0, P1, P2, P3. Okay, so R1 minus R2 minus R1, R2 minus R1, that's 0.75 minus 0.5. That's gonna be 0.25. Then R3 minus R2, that's 1 minus 0.75. 1 minus 0.75, that's gonna be 0.5. Okay, so those were intervals. Then let's calculate precision values, or what do we need to calculate them? We mentioned them. We need this value, which is actually P over R1. We and this value, which is P over R2, and this value, which P over R3. So we can compute the area. So we can compute the area. Let's compute the area for each interval. Okay, that's gonna be let's recall to this formula, as you can see. So average precision, which is the area, is given by, of course, R1 minus R0 times P1. If you want, we can call this P1. I know this is P0. This is P1. This is P2. This is P3. So times P1 plus R2 minus R1 times P2 plus R3 minus R2 times P3. Okay, we have calculated R1 minus R0, that's 0.5, and we have P1 here, 0.8. We have calculated R2 minus R1, that's 0.95, and we have P2 here, 0.6. Then we have calculated R3 minus R2, that's 0.25, and we have 0.4 here. This is going to be 0.4 plus 0.15 plus 0.1. The summation gives us 0.5565. Okay, so this is the average precision. Yeah, average precision equals 65%. Okay, so this is the manual calculation. I hope everything's clear. And you may wonder, you may ask me, why do we have to calculate this while the model does it to us? But if you're aiming to write your own model, you need to know how a model does what it does. Because later when you write your model, you will give it, you will program the matrix, how it will be evaluating its performance. So you need to know to understand how it does what it does. That's why I'm bringing about the calculations that's done normally done by the model. Thank you. I hope you enjoyed these calculations. If you don't like mathematics, that's okay. But you don't need to dislike mathematics. It's not that hard. Bye.